recording. Oh yeah, don't forget to record.
Thank you. You guys are way too active for Friday.
Man, I skipped my first class, so I have a little extra energy.
Oh, good job. I'm fine. So, this is 11.4. 11.4. That's the only one we did not cover yet. And it's not very long chapter, so it should be fine. Yes.
Did you link or?
Yeah, I did. Let me know. Tangent planes and linear approximations. Last time, right before the end of the class, I showed you the idea. Now let's work with formulas and do some form of examples to make your life easier. So, if you want to recall, let me know if it's there or not.
Yeah, it's there.
If you want to recall, in calculus 1, we gave you this. What is the equation of the tangent line? Y minus y sub 0 equals slope f prime at a x minus x sub 0. How to convert this into 3 dimensions? It's going to be like so. It's called an equation of a tangent plane. Plane that touches your surface. Because if you remember, in 2D, it was a curve and a line touching the curve. Now we have a surface being touched by tangent plane, and touch, the word tangent is translated as kiss, so it makes one person touch, kiss. Surface z equals f of x comma y at some particular point, 3-dimensional point, as you can see. This is the formula that will go to the test, I'm pretty sure, so you better memorize this. Basically, we need to add third dimension somehow. Instead of f minus x sub 0, now it's a z minus z sub 0 equals, instead of first derivative, slope, now we have partial derivatives. Partial derivative with respect to x and partial derivative with respect to y, each multiplied by the x minus x sub 0, x minus x sub 0. It's the same thing. It's the same thing I just showed you. So compare. It's the same thing, just because we have now more derivatives, you know, you need to just consider all of them. If you have more partial derivatives, bless you, then you just add them up. That's why we're introducing it after introducing partial derivatives. Now, do you remember?
September.
No, I actually do.
Yeah,
Good job.
it was
Tuesday.
Good job.
Yeah.
So, in two dimension, there was a curve. And then the equation of a tangent line looks like this. We tortured you with this question on the tests in calculus 1 and 2. So we told you that maybe if you zoom in and then your tangent line looks very close like a function, why in the world you would work with the function if you can work with the tangent line? So tangent line also is working as approximation tool. Specifically, I showed you, I think, Desmos last time, right? Specifically, do I still have it? Nope. Okay, this one is also good. Tangent, this is more about partial derivative, but still. Tangent line in each point tells you how the surface is changing, increasing, decreasing, maximum, minimum. See how it changes the angle. We know it means increasing, decreasing. But also, if the tangent plane is very close to the surface, we can use that as approximation of the graph we need. So, let me see if I have it here. This fun surface, for example, looks very flat, actually. Yeah, it spins, but it's pretty flat. So at any moment, it would be just wise to use tangent plane instead of the curve, because tangent plane is easy to work with. It's a piece of paper. So instead of something curly, you take a piece of paper and put it on top and say, you know what? It's approximation, plus minus couple decimals, it's the same thing.
Wait, so is it the flat piece of paper making that shape?
Yeah,
is it the shape making that flat piece of paper?
So in this case, it's a shape.
Totally serious.
No, it's you know those nasty worms?
What?
Somehow that's how I see it. I don't remember how they call it, the flat worms.
Tapeworm.
Yeah.
Oh.
So they are flat, but they curve. So at some point, you can technically speaking make them flat and put a piece of paper on them and use that instead of calculating how long they are.
Oh.
So kind of approximation using planes is a smart idea.
Thank you.
That's a weird example I just gave, but like, Write this down.
Ooh, rainbow.
Linear approximation is approximation. Why you did not do it? Come on. Linear approximation L, we always call it L, is basically what we did. We moved this z sub 0 to the right. That's how we got it. So, to be honest, it's the same thing. It's not a new formula. We took this and moved it to the right. So now it's z equals, but z will be approximated by L equals. So that is z sub 0 plus, and everything is the same thing. That's what we did. This whose graph is a tangent plane to the point is called a linearization. Linearization or linear approximation of the surface at that point. So we can say that my function is approximately that linear approximation. Linear approximation or the tangent plane approximation of f at A and B. I will show you 3D graphs on that. So let's see if it's the same thing. Oh, okay, never mind. Oh, it's the same. And here it is. Here's the idea I mentioned last time. Here is the shape of the surface. We found tangent plane at the point, and it's a plane. If I zoom in, looks like it's pretty close. If I zoom in even more, looks like it's very close. So maybe it makes sense to use this plane instead of the points on the surface. If the equation of the surface is too complicated, find this distance, and that will be an error. And then say, yeah, the answer is 7 minus 5 and 3 with the error of 0.0015. So that's the idea. We did it exactly the same thing in calculus 1. The closer we get, the much more the surface at the tangent plane and the tangent plane agree with each other. This is your homework. Let's find the equation of a tangent plane to the paraboloid. Let's do that. Paraboloid. Loid, paraboloid. So, the formula says, again, your best confusion for the, I would say,
The thing you might get confused on most.
your best struggle on the test is to remember the formula, right? So, equation of the tangent plane starts with finding derivatives, but in 3D, it will be hard for you to remember the formula. So, let's remember the formula, yes.
Are you not allowed to give it to us?
What?
What a formula sheet. Yeah, are we not allowed a formula?
Oh, I keep asking this question every time and they're not allowing. In the University of Utah, we did allow formula sheets.
This is a
Wait, so I
memorization
get one for physics, but I don't get one for calculus?
Yeah.
Professor, what happens if you accidentally
What?
What happens if you accidentally leave one in the test?
Leave the formula on the test?
If you accidentally leave a formula sheet in the test, what happens then?
No, there's one.
We don't do that. That would be weird.
Yeah, wait, actually, Jacob had a good question. What if we got a tattoo?
Actually, though, I don't have
Like, that's legitimate.
X minus X sub 0.
Tattoo on your finger?
And then, well, yeah, and then, like, if I could say it's like a religious thing.
Okay, you guys. You all disappointing guy. He's sitting here and he's like, those kids are so noisy. I'm tired of this. I'm tired of this. I just want to learn the formula. Let's do See? Hello. So, your first job is to remember the formula. Please remember the formula. That already gives you points in the test. Good job. You remembered it. Now, step 1. I would even put like this. Step 1. Find the derivatives. Because you remember synonym of tangent? That's derivatives. In 1D, 2D, 3D, still derivatives. So, that's for you. You can go around if you want. Then, let's find. Now we have several derivatives. Z depends on two functions in this case. It is z that depends on x and y. Thus, we will have two of derivatives. F with respect to x and f with respect to y. This is right now, you're going to do this on your quiz just without any context. Just practice finding partial derivatives. F with respect to x, derivative with respect to x, derivative with respect to y. This is going to be on this quiz. When you're taking with respect to x, 3y squared gives you 0. This is a constant. When you see that x is an only variable, 2x, done. When you take the derivative with respect to y, your brain should switch really fast, and now 3y squared is, but x squared is 0. Nice. So step 1, you find, I would even do this. Step 1, you find partial derivatives. Partial derivatives. Step two, you plug the point, just like we did in calculus 1. Let's do it here. Step 2, you plug the point. One of the notations is a bar with the point, or you can just do like this. What point 217 equals? So the partial derivative does not have 7 in it. That's what I also put in the quiz. That should not confuse you. This is x, this is y, this is z. So just ignore the one which is not there. Don't be freaked out if you see 5 inputs, but there is only a 2x. That's fine. 2 times 2 is 4. Does it make sense? It's fine to have more dimension than you actually need. So that's the point. Partial derivative with respect to y at 2, 1, and 7 is 6 times 1, which 6? So these are my slopes. These are my 2 slopes. Slopes, m. So we sometimes do call them m1 and m2. Where do they go? They go here. This formula actually is a little bit not nice. I would do it like this. F sub x at the point, just like they show it here. Let me be consistent. At the point, x sub 0, y sub 0. And this one, partial derivative at the point x sub 0, y sub 0. These are slopes, m1, m2. So it's the same formula, we're just kind of expanding into upper dimension. Are we done? Do we have everything? Let's check. Remember how I was teaching in calculus 1? I told you, let's check that we have everything. We did found the first slope and the second slope. X sub 0, it was given, what is that? 2. Y sub 0 was given, what is that? 1. Sometimes z sub 0 is not given. How to find it? Plug in what to what? To the original. If you plug 2 in 1 into original, it should give you 7. And it's true, check. 4 plus 3, that is 7. So, in this case, your lucky 7 is given. This is z sub 0, that is 7. So maybe write down x sub 0, y sub 0, z sub 0. So the third step, sometimes you need to find y sub 0, but if not, plug everything into the formula. Z minus z sub 0, that is 7, equals slope number 1, that is 4, x minus x sub 0, which is 2, plus slope number 2, 6, x minus, no, that's y minus y sub 0, which is 1. And if you have more dimensions, you keep going. Plus this, and so on. Plus this, and so on. 4, that is a scary cough. Z equals 4x plus 6y. And then you have to calculate all the numbers. I see it is, well, if you simplify, I think it is minus 7. Minus 8 and minus 6. That is minus 14 plus 7. Yeah, it is minus 7. So that is writing the answer in terms of, remember, y equals mx plus b. In 2-dimensional, it will be z equals mx plus my plus b. It's m1 and m2. Pretty cool idea. Yes.
On the exam, can we leave it as step 3, or do you want it as step 4?
I will be deciding when I created the exam, so I'll let you know. If I say simplify, then you will have to. If I believe it's too long in algebra, and you guys make way too many algebra mistakes recently. So, like Carla said, I can do double integration, but I cannot do fractions, you know?
Because this is calculus, not algebra.
Yeah, I kind of agree on this. Yeah.
Shouldn't it be plus 7?
I don't know. Maybe.
No, that's an algebra. It is minus 7.
Too lazy to calculate.
See, professor did algebra errors.
Yeah.
No, Navi is doing algebra errors.
I think it's minus 7.
It
Yeah.
is minus 7.
Now, linear approximation. Let's do one more problem and do the quiz.
Yay!
Normal math.
Example 2 about linear approximation. Linear
Wait, but on algebra.
approximation. So, let's see. Consider the function. Let's see. Usually please. Consider the function f of x comma y equals a nasty square root. You will have to do quotient rule today. Yay! On the quiz, quotient rule. Either the 2y. So, you need to find, or use, let's do like this. Use the linearization, that's a long word. In Russian it's linearization, yes. Linearization to approximate is it double P? Yes. To approximate the function at, and this is what you're gonna have in your homework. To be honest, I don't like putting these questions on the test, but sometimes students tell me that they like these questions. So I will ask before the exam too, do you like this particular question? Do you like it? If you raise the hand, if majority says we get it, I will put it on a test. If most of you says I hate it, I usually don't put it on a test. Because linear approximation is more applied math and computer science math. So engineers also do that, but pure mathematicians don't do it, so I don't feel like doing it.
If you don't raise your hand, we have one less problem on them.
No, they will be just different problem. It's not that simple.
It will be easier problem.
Not necessary. Not necessary. So step 1, guess what? Remember the formula, okay. Linear approximation is L, in this case depends on two functions, x and y, is. So remember there was z minus z sub 0, that's exactly the z sub 0 comes here. So it's gonna be f, it just renamed, f at, let's see. What is about 8 and 0? Oh, okay. Let me see how to explain this. Yeah, at 7.5, 0.2, that kind of thing. Plus the first, let me tell you what I want to do is, just a second. No, oh, I see what they wanted. The function from, yeah, that's what I do. I see. There's a continuation. From the different point, 8 and 0. So this is what is happening here. There's a surface, and instead of, this is complicated, hard numbers. It would be nice to find the tangent plane and plug easy numbers which are close to hard numbers. 7.5 is close to 8, 0.2 is close to 0. So objectively, it's just easier to calculate that. Thus, that's what I was thinking. Which one should I show you? So, we are going to find a tangent plane first. So we're going to find, let's do it like so. L of x comma y, and we're going to find f of 8 and 0 instead. Plus, and then everything else is the same. Partial derivative at 8 and 0, x minus 8, so that's already given, plus partial derivative of 8 and 0 times y minus 0, which is just y. So we're going to find this instead. And then we're going to say that, and then we're going to say that L of that number they ask us to find, 7.5 and 0.2, will be approximately L at 8 and 0. So that's kind of the idea here. And that's why the confusion between which numbers to use. That's why I don't like to put it on a test. Students get confused, I think. But the steps are straightforward. the steps are, we find partial derivative with respect to x, we find partial derivative with respect to y, which we are going to do right now in the quiz anyways. 1/2 goes down, 1 over the square root of copy x plus e to the 2y chain rule times, and now derivative of the inside function with respect to carefully what do you need. So if I'm taking derivative with respect to x, what is derivative of this with respect to x? 1. That's very nice. With respect to y, 1/2, 1 over x plus e to the 2y. Now you should be careful. What is derivative of the function inside with respect to y? 2e to the 2y. So you're gonna have this on the quiz right now as well. This like e to the 2y and stuff like that. So you got these. Then partial derivative at 8, 0 is plugging in, and I get 1/6. You just plug 8. Partial derivative of y with this inside, you plug 8 and 0, and you get 1/3. So these are my slopes, M1 and M2. Then the first L of x, y is yeah, 2 cancels out with 1/2 over here. So it's going to be f, also don't forget we need to have f of 8 sub 0. So let's find the original. We don't have it actually here. So step 1, we found this couple. Step 2, we found this couple. Step 3, we don't actually have this piece. The very first piece is missing. What is f at 8 sub 0? Plug into the original. Plug into the original. Original is the square root. The square root is 8 plus e to the 0, which is 1. So it is square root of 7, I think? No? That's 3. 9. Oh, square root of 9 is 3. Very nice. Oh, that's a good number. So this is my slope 1, slope 2, and then y, no, and then f sub 0. You can call it like so, or z sub 0. That's also notation. Now you can build a formula. L at of x and y can be written. That is 3 f of 8, 0 plus slope number 1, 1/6 x minus 8 plus slope number 2, 1/3 y minus 0. That is my tangent plane. We claim that this tangent plane is very close to the surface. So instead of using the original equation with a horrible square root, like this is what we kind of claim. This is hard. This square root is just hard. E to the something is hard to approximate. Instead, we can use this. So use this equation instead of original to approximate whatever you want to approximate, to approximate stuff. Does that make sense? We found something close to 8, 0, and now we can approximate things which are not too far, of course, because the surface can be like folding around. Let me finish and I'll end the question in just a second. So they want us to approximate this nasty number 7.5, 0.2. Instead of plugging into the square root, we're not going to do that. We're going to plug it into this tangent plane. I'm going to say, yeah, it's approximately the same thing. So 3, why did 3 disappear? Doesn't make sense. But okay. Oh, it's already simplified. It's going to be 3 plus 1/6 and then 7.5 minus 8 plus 1/3 times y, which is 0.2, which is approximately 2.9833. And we say this number is approximately the number if we would get if we plug it into the original one. We can check using hardcore, say, NASA calculators. NASA computers are really good, one of the best in the world. We could actually just plug into the original, and see what the NASA calculator is going to say. So, for example, we plug in 6.5 and 0.2 into the original square root, which is 7.5 plus e raised to the 0.4. And that one thinking, and give us 2.9986, which is very close. Thus, if you don't have an NASA calculator, you can use approximation of a tangent line. And the difference of these two is the error. Make sense? So the error is the difference of these two. If your error is small enough means your research approves it. And then you can keep that result. If your error is big, your lab mates or your instructor or your director sends you to the national labs and they will calculate it there. There was a question, I just said it. Yeah.
Does the approximation only work if it's near the point?
Yeah.
80?
It's an amazing question because she's asking. So here's the nice pictures I have. Let's say this circle. I have very good this circle over here. Not a circle, a sphere, a ball, right? And then you should not use, when you fix your tangent plane over here, then you better choose points around the point where it kisses the surface, right? You're not supposed to take the point over here and claim that they are close enough, like that's a line. You should not do that. So if you need to find another point, say this is Jupiter and you want to approximate the location of your drone on Jupiter, and you need it here, you have to recalculate completely with tangent plane. Makes sense? But for this tangent plane over here, points around it will be close to the tangent plane. So now you don't have to know how the Jupiter looks like because we don't, it's too far to figure out. But we do know how the tangent plane looks like, mathematically calculated. Now it's easier to use the plane to approximate points over here. Imagine tangent plane gives a shadow to this planet. So if the distance is not too big, the results will be pretty close to the actual ones. Yes. So does that make sense? Yeah.
What would be acceptable error for research stuff?
Good question. What is the acceptable error? In calculus 1, I was explaining, if you work with space science, acceptable errors are huge. So I do know a friend that works for NASA in the Los Alamos lab. She's a mathematician, applied mathematician. So they say we'll try to figure, it's called Space Defense Program. If there's a meteor passing by, can we like shift the meteor and maybe it will change direction? She says it takes years to calculate it mathematically, and then the thing is, even if we miss, so like the error was there, we missed the moving meteor, it's still acceptable for the space science because that's how huge the distances are. But if you work with the cancer, or even if you have a robot that is nowadays performing appendicite surgeries for you, I did see that actually on my friend. And then that error is kind of important because a couple millicentimeters off, and that might end your life. So that depends on the field. Depends on the field.
Isn't it important about meteors though? We don't want to get bit. Yeah. We want to know.
Yeah, so they figure out different scenarios.
Well, if it's going right at you, it's going to be hard.
That is good enough for this chapter. So I can cover more on Monday if you want, but to be honest, this chapter is always small. So we covered 11. This was 11.4. Yeah, just a second. 11.4, and then before that we covered 11.3 and 11.5. So it's plus 11.5. That's why you have 3 homeworks due Monday. If you really need, I might extend some of them, but I will decide on Monday. Let's have quiz.
I think there's a typo.
No, really?
Yeah. It's like right here.
Oh, I did not check any of this.
Out of square.
No.
Because this is your step.
This is the same. Wait, which one?
These, well, for these three, you forgot the squares.
No, show me.
Oh, here's the actual.
The actual. Yeah, there should be squares. Oh, come on. I was afraid it's going to happen.
Write it up on the board.
Yeah, let's write it down. Let's give them. Okay, let's give it to them. Careful, don't give big example.
Yeah.
Yes.
Put you outside for a second.
Yeah, sure.
He's like, I only have Isn't the one that Sometimes you just put the PDF on there. It's not usually on campus, it's on the grade.
If you want to make it smarter, Remember, she only had that one question wrong. Yeah, that's just a question. I don't know why. I don't I know that, but I'm saying you can look at it.
Yes, let me just do the whole calculation mentally. Such a good idea.
Not that. I believe you. You can look at it and go, man, this is the steps I'm taking to the problem. Overall.
Do you want to write the typo up?
Oh, it should be big K.
Should we tell them?
Alright.
Blah, blah, blah. Yeah, and then I would change PDF online, I guess.
Yeah.
Yes, let's
I'll
do
write it up.
Let's tell them.
Yeah, but how is
Please fix. There's a typo. Unfortunately, there's a typo.
Which one?
Number 5. C should be z equals x squared minus 3y squared.
Okay.
And one more.
And D should be
Squared. And D also, the square got lost. I don't know why. I will change the PDF as well later.
Professor, the PDF wasn't on campus.
Yeah, I will put it right now. Yeah. Oh, sorry about that. You can edit actually. Yes. I'll put it right now. You don't want to do this? You don't have to do that. Yes.
I'll take that.
Thank you. Yes, just a second. I did forget about you. That's true.
You know, that's always the
I
first
had a feeling I forgot something.
Did you remember to record?
Yeah. Okay. Go.